All right, welcome to the weekend review for the central nervous system. Again, this is MS-LS1-8, and we're focusing on nerves and neurons. Um, Keep in mind you have a midterm coming up, so prepare for that. We'll talk about that later on this week. Your standard, what you should be doing is gathering and synthesizing information that sensory receptors respond to stimuli, and they'll send messages to the brain for one of two things: either immediate behavior, which is more like your peripheral nervous system, sensing and responding, or storage as memories, which we think of as being more of your central nervous system, where information is stored. So again, focus primarily this week on the central nervous system, storage as memories. If you didn't get a chance to ask a question to Dr. Dombrowski, if you had one, you might be able to get one in before she gets them all answered, but time is running out. So if you're getting this on the weekend, be sure to double check and see if you can't ask your question and squeeze that in there. Let's see. All right, a couple main points about the central nervous system that we need to cover. First being, the central nervous system is made up of your spine and your brain. So your brain is part of your central nervous system, but so is your spine that runs on the central line of your body. We think of the spine, the spinal cord, as kind of being like the power cable that all of your peripheral nervous system can plug into. So as sensory information is coming down your sensory neurons, it's going to go to your spinal cord and relay that information up to your brain so you can decide what to do with it. If you decide to move, your brain will send a message down your motor neuron to make a movement. So think of the spinal cord as the connection between your brain and the rest of your body. And since this standard is related primarily on how we store information as memories in our brain, we're going to focus primarily on the brain. I'm not going to talk much about the spine. The brain is composed of several main sections: the cerebrum, which is kind of the thinking cap. On top of the brain is the wrinkly portion that we all think of as being the brain, the cerebellum, and the brainstem. There's more to it than that, but that's all we really talked about. That's all we're going to cover for this standard. The hippocampus, we discussed a little bit, is related to short and long-term memory, and the basal ganglia we talked about kind of cooperating with the cerebellum for more muscle memory related tasks. These rest just above the brainstem and what's called the limbic system. Again, we didn't focus too much on those terms because, again, primarily we're focused on gathering information for how the brain stores information as memory, whether it's short or long term or muscle memory. The cerebrum, that thinking cap portion, that's the wrinkly part that you think of as being the brain, that's broken down into 4 sections: the frontal, temporal, occipital, and parietal lobe. We'll talk about that in a second. The hippocampus, we talked about it being kind of like a chef that reads the recipe of a memory and recreates it when the information is being recalled. So without your hippocampus, your short and long-term memory, it's not possible. You won't be able to do it. We talked about the famous patient, Henry Molaison, referred to as HM. He had his hippocampus removed, and he could no longer form or recall memories. All right, again, going back to those 3 main parts of the brain, you have the cerebrum, and if you follow my mouse, that's this part right here, the kind of oven mitt looking part of the brain. It's all wrinkly, and that's really the portion of the brain that kind of makes us human. It gives us our emotions, lets us think, interprets our senses. It does a lot of what kind of makes us us. That's your cerebrum. You have your cerebellum. That's going to be this little ball of yarn looking thing underneath it, or kind of like spaghetti. And I said how it kind of looks like spaghetti noodles or vermicelli. And that's how I think of it, as being the cerebellum, because it belongs in my belly. Not the cerebellum, but spaghetti. Anyway, the brainstem is at the bottom here, and it kind of is the little connector piece between your brain and your spinal cord. Didn't focus too much on the midbrain or the pons. Again, we talked a little bit about the limbic system that's further up into the central part of the brain here, resting on top of the brainstem, and that would be like your hippocampus and your basal ganglia. Again, both responsible for different types of memory. Okay, So when you think about different parts of the brain, I tried to use the acronym flat top or FTOP, right? Being F for frontal, so this frontal area is your thought, memory, and behavior. We talked about that being part of the brain that's still kind of under development for a lot of you guys. So when we think about risk-taking behavior and not thinking things through, it's not really excusable, but you do understand that when this part of your brain is still under development, you're going to have some interesting behavior sometimes. T, the temporal lobe, that's right here. This is on the side where your temples would be, on each side of your head. Because again, this is two hemispheres, they're both on each side. So your temporal lobe is going to focus on your hearing, learning, and emotions. So it's right next to your ear, which is kind of how you can realize that it's all about hearing, storing those memories. The occipital lobe is back here in the back, this green area, and this is responsible primarily for your vision. It's kind of interesting that your optic nerves are up here, your eyes, and it doesn't get translated till back here in your occipital lobe. We talked about the prefix for that, the OC, like an Oculus Rift, that virtual game, virtual reality kind of headset, ocular degeneration, that's macular. Anyway, ocular does with the eye. So occipital lobe would be your O, and your parietal lobe is sitting here on top, right there. That's the blue area. And that's going to be primarily for your senses. It says language here, but primarily it's going to be how you sense things, interpret sensory information. So here I've got some dudes with some flat tops, or F-top. Again, however you choose to remember it, it's up to you. But again, you would want to know those four kind of main basic divisions of the cerebrum. Again, this is just primarily for the cerebrum, here, the oven mitt, and your cerebellum is below it, and your brainstem would be right there, that purple part. Okay, because of the importance of the hippocampus in terms of recalling memory, we spent some time on that. Again, talking about it as being kind of like a chef in a kitchen. So your memories are not really fixed. It's more like they're recomposed. So you have like a recipe of something that comes in, you're trying to recall a memory, and it's just pulling stuff from different places, and it will reconstruct that memory. Now, what's wrong with that is sometimes you can recall the wrong things, or if you have gaps, your brain will fill those gaps in with information that might or might not be correct. So we talked about the importance of encoding information so that it's reliably recalled. So the more you encode something, the more likely you are to recall it correctly later. Which is why, again, when we take our notes, we focus so much on encoding this information in ways that we can recall it easily using acronyms and whatever else. We also talked about repetition. So the more often you recall something, the stronger those pathways get. We talked about neurons being able to move around and make connections across those synapses. And the more often information is passed across those synapses, the stronger those connections become. And it's easier for the hippocampus to recall that information, and it's less likely for you to fill that information in with something that didn't actually happen, or be suggested by somebody else that something happened. All right. Next thing we focused on when we talked about Henry-Molaison was the difference between procedural and declarative memory. They're big words, but here's what they mean. It's not that complex. Procedural memory, it's kind of like muscle memory. So being able to juggle, being able to ride a bike, that would be procedural memory. And procedural memory is governed, again, by the basal ganglia, which is part of your limbic system, and the cerebellum, which also governs some motor movement. And Henry-Molaison, when he had his hippocampus removed, he couldn't remember anything. But when he was asked to do tasks that required muscle memory, he increased his ability to do them. So he improved each time, which is how they realized that there's a difference between muscle memory and doing something over and over and over again, and what we'll talk about in a second, which is declarative memory, which is like facts and figures. So the ability to recall, if you think about like a vacation that you went on, you can recall that information, because you're able to use your declarative memory. Your hippocampus is active in reconstructing those memories and pulling them together. And it will pull that information primarily from your cerebrum, so your different lobes, your frontal, temporal, occipital, and parietal lobes. So anyway, the frontal lobe is responsible for long-term memory storage primarily. So there's a hippocampus frontal lobe connection for memory. All right, one of the last things we talked about and we did to kind of give us a visual for storing this information, a way of encoding it so we can recall it later. For a lot of the visual learners out there, which is most of you, like we talked about, we broke down last week the peripheral nervous system. So that's what you'll see over here is the peripheral broken down into sensory, motor, etc., etc. This week, though, the central nervous system. So the central nervous system is broken down into the spine, which we're not going to talk about much, and the brain, which we talked about a lot. And that brain's broken down into three main categories: the cerebrum, the cerebellum, and that brainstem. We talked about the cerebrum, just to recap, being the frontal, there's your F-top, your flat top, frontal, temporal, occipital, and parietal lobes. It's important to know what those kind of do. There's the cerebellum, which rests, that ball of yarn or spaghetti or whatever you want to call it, right beneath the cerebrum, and it's responsible for a lot of your motor, your movement, ability to maintain your posture. That'd be a characteristic governed by the cerebellum. And then finally, the brainstem, which we focused really on the structure sitting on top of the brainstem, which is the limbic system, which houses the hippocampus and the basal ganglia. Now, I color-coded these to make it a little bit easier for you. The light blue is going to be your short-term and long-term memory, and the dark blue is going to be muscle memory. So all of these, the light blue here, all the lobes of your brain are responsible for retrieving and putting together short and long-term memory. And the hippocampus is kind of like the chef or the composer that puts a lot together. And your cerebellum and your basal ganglia are responsible for some of your muscle memory, the ability to juggle. So that should just about wrap it up. I will see you guys in class.